All right, today's lesson is lesson number 52. This is solving systems using substitution. So we are solving systems of linear equations, which means we're looking for the point where two lines intersect. These are the steps to solve using this method. The first step is to solve one equation for one variable. So that could look like y equals something or x equals something, or maybe you have different variables like a and b, so you might have a equals something as your step one. Next, you're going to substitute that expression into the other equation. So whatever you get next to y equals blah blah blah, this is what you're going to substitute into the other equation. Okay, then step 3 is you're going to simplify and solve the equation. Step 4 is you'll substitute that into the original equation to find the value of the other variable. Then step 5 is to check the solutions in both equations of the system. Remember, the solution to the system is where both lines exist because it's where they intersect. So when you plug the point into both equations, you should get true statements. Okay, so let's walk through this first example using our steps. These are my two equations. So for step 1, when I need to solve one equation for one variable, I can see that I already have that done for me, right? The first equation is y equals 4x, so that's already solved for y. The next step is to substitute that expression into the other equation. So I have a y term here in my second equation, and instead of writing y, I'm going to substitute in 4x because those two things are equal. So I'll have 3x plus 4x equals negative 21. Okay? Then step 3 is to simplify and solve that equation. So these are common, or they're like terms, so I can combine them. So this is 7x equals negative 21. Dividing by 7, I get x equals negative 3. Okay, so that's the first part of my answer. That's the first part of the ordered pair, right? So next, I want to substitute that back into either equation to find the value of the other variable. Remember, my x was equal to negative 3. So I'm going to try to plug that in. I think this first equation is nicer, so I'm going to plug it back in there. So y equals 4 times negative 3. 4 times negative 3 is just negative 12. So my solution to the system is the ordered pair negative 3, negative 12. Okay, then I need to do step 5, which is to check the solution in both equations. Remember, this was my solution. So I'm going to plug that into both equations for x and y. So the first equation is y equals 4x. I'm going to see if I plug these in, negative 12 equals 4 times negative 3. Is that true? Well, yeah, 4 times negative 3 is just negative 12, so that's good. In the second equation, I have 3x plus y equals negative 21. Plugging in negative 3 for x and negative 12 for y. I would multiply this to get negative 9 plus negative 12 equals negative 21. Then adding negative 9 and negative 12, I get negative 21. So negative 21 equals 21. That's a true statement, which means that my solution is correct. Okay. Let's look at another example. Again, I'm going to solve one equation for one variable. So let's try solving this equation for x. Okay, it doesn't always have to be for y. I can solve for x too. So this becomes, it's starting as x plus y equals 10. If I subtract y from both sides, I get x equals negative y plus 10. Okay, so there's my step 1. Step 2 is to substitute that expression into the other equation. So I'm going to substitute this in for x because they're equal, right? This equals x. So I can substitute that in for x in my second equation. So that becomes 5 times negative y plus 10 minus y equals 2. Okay, then I'm going to go on to the next slide for step 3, which is to simplify and solve the equation. Okay, and here's my equation from the last slide. So to simplify, I'm going to distribute the 5. So this becomes negative 5y plus 50. Then I have minus y equals 2. I'll subtract 50 and then combine my negative 5y and negative y to get negative 6y equals negative 48. Dividing by negative 6, I get y equals 8. Okay, a negative divided by a negative gives me a positive, right? So I have y equals 8. Now step 4 is to substitute that back into either equation to find the value of the other variable. So if I substitute this into the first equation for y, I have x plus 8 equals 10. Subtracting 8, I get x equals 2. Okay, so that means my solution to this system, the ordered pair, would be 2, 8. Okay, and then of course step 5 is to check the solution in both equations. So plugging in 2 for x and 8 for y in the first equation, I get 10 equals 10. In the second equation, I get 5 times 2 minus 8, and I want to see if that equals 2. 5 times 2 is 10, so 10 minus 8 equals 2. So that solution works for that line as well. Okay, I'm going to skip this example for the video. Okay, so for this example, I want to first solve one equation for one variable. I see that in the second equation, this b is practically by itself. It has a coefficient of negative 1, which is going to be helpful. So if you ever see a variable with a coefficient of 1, that's probably the one that you want to solve for. It's going to be easier for you in the long run. So let's take this off to the side and solve for b. So I have 2a minus b equals 5. If I subtract 2a, that gives me negative b equals negative 2a plus 5. And then I just have to divide by the negative 1 so that I can get b by itself. And that'll equal 2a minus 5. Okay, then I'm going to substitute this in to the other equation for b. So I'll have 2a minus 3, and then instead of b, I'm going to put what I just solved for. So this would be 2a minus 5. Okay, so this says 2a minus 3b, right? And that's going to be equal to 7. Okay, then I'll distribute the negative 3 actually, so I get 2a minus 6a plus 15 equals 7. Combining like terms, I get negative 4a equals, subtracting this 15, gives me a negative 8. Then dividing by negative 4, I get a equals 2. Alright, so I have a value for a. I need to plug that back into one of my original equations to get a value for b. So plugging it into the second equation, I get 2 times 2 minus b equals 5. 2 times 2 is 4. So I can then subtract 4 and get negative b equals 1. Divide by the negative 1. I get b equals negative 1. Okay, if I want to write this as an ordered pair, I would say 2, negative 1 then is my solution. And I can check by plugging that into both of the original equations. Alright, this one is relatively easy. X is already solved for, so you just have to substitute that in here. I'm not going to go through that one on here. This one, I look at the variables in these two equations, and I can see that this x just has a coefficient of 1. So that's probably the one that I want to solve for. That's going to be easiest. So I can solve for that by subtracting 3y. And I get x equals negative 3y minus 9. Okay, then I can substitute this in for x in the other equation, right? So, okay, so doing that gives me 5 times negative 3y minus 9. Again, that's just like saying 5x, right? Because I just said this is equal to x. So 5 times that plus 8y should equal 11. Then distributing the 5 gives me negative 15y. Then 5 times negative 9 gives me negative 45. And plus 8y equals 11. Combining like terms, I get negative 7y minus 45 equals 11. And then adding 45 to the other side, I have negative 7y equals 56. So y equals negative 8 when I divide. Then I can plug this into either equation to solve for x. So I'll plug it into the second equation, which gives me x plus 3 times negative 8 equals negative 9. So this is x minus 24 equals negative 9. Adding 24 gives me x equals 15. Okay, so my ordered pair, the solution to this system would be 15, negative 8. Okay? All right, that's it for today's lesson. Thank you.